We'll be running a product test trial today of our SUS9-B. To the bottom is our newer style that we have developed, and to the top is our one that's already in production. We'll be testing the swing away ears, the SUS9Es, left and right, and we'll be testing the compression ring and the screws that hold the SU rod to the actual SUSE. We'll be using a Craftsman torque wrench and a Berkeley weight gauge. Also, we'll be using a 1/8 and 5/32 Allen wrench and a 3/8 open face wrench. The hardware that we'll be using is TW480 FDM. Test 1 will include using our weight gauge. We will pull pressure on the SU260 rods to simulate tone, increasing increments of 10 pounds of pull pressure starting at 10 pounds and ending at 40 pounds. After each test, we will examine for stress cracks, loosened screws, and failures. We will run this test 5 times on each side. Next, we will have to torque down our compression ring by torquing down the screws to a given inches to pounds ratio. On this new style, it takes 35 pounds of inches to pounds of torque to keep the SU rod from free spinning. There it goes and it clicks there, which means there's 35 pounds on it. There's a click there. Now it does not spin. Now we're going to test the SUS9B. It consists of the SUS9, which is this unit here in the middle, and the SUS9Es, which are the ears. And the SU260 is our standard rod, which is 9 inches. To test these, we apply force in this direction against the perpendicular axis where the headrest would normally be, which is here. So we have a mock setup to support the SUS9B. So the first test we do is we hold it here to keep pressure off the TW480 hardware, and you pull 10 pounds of pressure on it, and at that point it doesn't break, so that test is a good test. Then I jot my notes down and come back and test at 20 pounds and do the same thing. In this case, on this one, at 20 pounds it breaks away. We found a defect in it that we will fix. So I take those notes down, and once this breaks away, we have to replace this clip in order to have more results that were clear for the following tests. I do the same thing for both sides and jot down all my notes on that, and I compare those notes to what it would be with our older style SUS9B. Now I'll be using the Craftsman torque wrench here to test SUS9Es for the torque on the screws, what it takes to torque down the screws and how much torque they can handle on the actual ear itself. The ear includes the compression ring here, a ball inside there which tightens down on the SU rod, and in this case, with the new style, it takes 35 inch-pounds of pressure on each screw to tighten down the compression ball to where the rod will not free spin. So the way I begin with this is I start at 35 pounds and I go up to increments of 10. So I'd go to 45 pounds and I'd set my Craftsman torque wrench and tighten it down. So then I tighten down and then it snaps over. Tighten down and it snaps over. And I tighten down and then it snaps over. Then I go check for any failures anywhere. I look for stress cracks. I look for screws trying to dig in. I make sure my compression ring is directly parallel with the ear itself, and then I work my way up in increments of 10. I get to about 65, 75 inch-pounds per screw, and I disassemble it and look for any more damage, and then I continue up in my steps. So in this test I went to about 115, 125 inch-pounds per screw and found that the actual compression ring, which would have been here, on this actual unit here, began to go off of a parallel state compared to the actual SUS9. And what happened here was the screw here began to eat into the metal. It was digging in, and these two screws, every time I would tighten them down, would make this one right here dig in more. So at this point this is beginning to fail, and that's at 115, 125 inch-pounds, which is more than enough for the SUS9E to operate correctly. And at this point, I'll actually assemble everything back together, and I will test it to the point that it completely fails. Here you see the side that the actual compression ball is on, and there's some polishing here from that actual ball, which doesn't harm anything at all. So now I'll reassemble it and test it to its maximum potential, and at that point then I'll jot my notes down and submit my results and write up a conclusion.